logical reasoning. And so whether I'm talking to an English teacher or history teacher, they're grading papers, they'll comment, like aside from the obvious things like not citing sources and stuff like that, they'll say things like there was no logical flow to the argument. Right? They say it was all over the place. That's what they mean. They mean that there's no underlying logic to the scheme behind how you outline the information. All right. So if you're creating, for example, a persuasive argument, you really need not only to get the reader from point A to point B, but you have to connect every little detail along the way. All right. And so it's kind of like every essay you write is like a legal battle, a court case. If you've ever witnessed any of that, you might hear some things like, objection, assuming facts not in evidence. If you haven't presented the evidence and entered an exhibit into evidence, then the discovery and all that stuff, then there's no way that you could refer to that evidence throughout the trial. All right. And so that's what's going to happen here, is that you can look at a geometric figure. I'll ask you to prove that it's a square. All right. You could actually kind of interpret that as prove this figure is guilty of being a square. All right. So the innocence until proven guilty is still a thing. All right. Even in mathematics, even in geometry. So when I say prove that something is a square, we're assuming that it is innocent of being a square, and you have to lay out all the evidence to convict it and prove it guilty of being a square. All right. So you can't get your conviction unless you've laid out all the evidence and presented it in an organized fashion. Now, the major difference is that this is a bench trial. It's not a jury trial. All right. So you don't have to convince the jury of the defendant's peers. That's not like that. You got to convince the judge, who is strictly looking at the logic of it. All right. So a trained logician. So that would be me, but I try to kind of suspend my disbelief is not the right word, but lofty standards in some cases, especially for folks who are new to this, at least early on, because it is so different, it is so weird, that you could think that you're presenting a valid argument and be off base, but you have like the gist of it. It would be a convincing argument, but it's not technically 100% logical. Right? In those cases, it still wouldn't be 100% correct, and therefore it wouldn't get full credit, but it's not going to be like it's wrong minus 1,000 points. It'll be minus like half a point, But it's also one of the reasons why we're going to go the group route for this, because if you can't convince your classmate or classmates of your argument, then there's no way you're going to be able to convince me, right? So that's a pretty reasonable way to go about doing things. All right, a lot of definitions here, but most of it's going to fall in the category of common sense. The symbols are a little bit different. So conjunction denoted by that almost A symbol, and I say it that way because that almost A references an and. All right, so conjunction, two things occurring in conjunction, one thing and the other thing happening together. All right. Disjunction, that's the opposite, not opposite by definition, but the symbol is the opposite. And, con and dis, you could think of those as opposites, but this is implying an or relationship. All right, one thing occurring or another thing occurring. And that's the one that people, I would say, tend to struggle with the most. And there is some aspects of implication that people can have a little issues with. I'll talk about that in a minute. a lot. But the symbol for a disjunction is the V symbol, and it's read P, V, Q is read as P or Q. All right. So the notation is going to be an important piece here because when we detail these logic proofs, we're going to have to write sentences over and over and over again. You don't want to have to write out the full-blown English sentence every single time. The symbolic notation is going to be an easier way to write it. Like, for example, if I were to say, if angle P is 60 degrees and angle Q is also 60 degrees, then angle R is 60 degrees. Prove that triangle PQR is an equilateral triangle. That's all well and good, but every time I have to write that sentence down, if angle P is 60 degrees and angle Q is 60 degrees, then angle R is also 60 degrees, I'd have to write that out 5 or 6 times. That's a lot of writing. All right? So instead I would say P and Q, and then I would use a sideways arrow to indicate the if-then relationship. All right? That's for an implication. All right, but specifically it's an if-then. Most of the time anyway. All right, so it's an implication that's already written there. Typically it's an if-then. But most importantly, it's a conditional. All right, you could say it relies on a condition. I cannot physically make the E, so we just got to deal with it. That's supposed to say then. All right. It has the premise-conclusion relationship. All right. So not quite subject-predicate, but kind of along those lines. Because if I were to say that, if Tommy is going to the racetrack, then he will win $100. There's a subject and there's a predicate, but specifically the condition would be Tommy going to a racetrack, and the result of that would be, assuming it's a true sentence, that he wins $100. Now, the weird part of that is, does that assume that he is guaranteed to win $100 just by going to the racetrack? Not necessarily. All right, and that's what we're going to be investigating. All right, so you know what? Honestly, I like the example I just came up with on the fly better than the one that I've had here in my notes. So we'll actually talk about the Tommy and the racetrack in a few minutes, but I'll just read this one. If my bread is green, then I will not eat it. All right. So the statement, if the bread is not green, that doesn't guarantee that I will eat it. All right. Perhaps it's wheat bread, and I hate wheat bread. I don't care for it. I don't hate it, though. It's pretty strong. All I know is that if my bread is green, I will definitely not eat it. So the conclusion is assumed based off of this premise. But if that premise is not true, the bread being green, I really don't know what the outcome is going to be. If the bread is, like it says here, wheat bread, I still might not eat it, but it doesn't guarantee that I am going to eat it. All right, so there's a lot of weirdness going on there, and we're going to talk about how to evaluate it in more detail in a little bit. But that it kind of brings into mind the weirdness of the implication. All right. If you score 90 or above in this class, then you will get an A. That was not me leaving like a fill in the blanks kind of thing. I just forgot to finish that sentence. So that's a typo. It should have said A. And I just didn't do it. All right. Now that whole, there's a whole paragraph there. But there's a lot going on with this question, because if the truth value of this sentence would depend strictly on whether or not you earned a grade 90 or above. All right, so the truth could vary from person to person. So the one thing I can say is that if you get 90 or above, then you're going to get an A. So that is my promise to you. That's what it says in the syllabus. All right, that's the contract language. All right, so the contract states if you earn a 90 or above, then you get an A. It does not say what would happen to you if you did not get that mark of 90. Let's say you get an 89. Contract language says if you get a 90 or above, you get an A. It doesn't say that that's the only way to get an A, though. All right, so if you got an 88, I could still give you an A and not violate the contract. All right, you can get a 70 and I can still give you an A. I'm not violating the contract. The only time I'm violating the contract is if you get a 90 or better and I don't give you the A. All right, that's a violation of the promise that I made to you. All right, so the other way around would be if you didn't get that 90 mark, I never stated what would happen. So you can get an 88 and I can fail you. All right, and I would not be violating the contract. It would not be very nice, but it's not against the language of the contract. All right, so that's what we got to think about moving forward is, am I keeping to the contract or am I violating the contract? And that's going to be very, very important as we evaluate proofs. But that's what all this pretty much means. The biconditional is a conditional sentence that works in both directions. So basically, I could change that sentence to include the statement if and only if. Now, it's kind of weird to say that because nobody speaks that way. The little notation here, that's the one thing that's not actually a typo. I mean, everything else could technically be considered. I mean, my grammar is atrocious. But IFF stands for if and only if. And so if I take that previous sentence and rephrase it to make it biconditional, I can actually just type it here, I think. Let me try it. If, it's a little big. I don't think I need 36 font. Let me go 14. Yeah. Might be a little on the small side. Make it red. If I don't want to mess up the color scheme here, so I'm going to work around that. It's really going to be you score a 90 or above in this class if and only if you get an A. So you score a 90% or above in this class if and only if you get an A. You play around with the tense. You can make it past tense if you want, and future tense all the way through, but that's the general gist of it. You score a 90 or above in this class if and only if you get an A. And when you read it like that, it just doesn't sound like natural language. But if you put the emphasis on the right syllables, then it tends to make more sense. It's more like you score a 90% or above in this class if and only if you get an A. All right? The reverse would be true as well.
Oh, that's what I was just going to say.
Right, because you could even say it would make more sense. You get an A if and only if you get a 90 or above. Right? But the biconditional allows it to work in either direction. All right? It's basically saying that the only way that you're going to get an A in the class is if you get a 90 average or better. All right? And so the example I have here, if and only if my alarm clock rings in the morning, then I will attend my morning classes. It's just an awkward phrasing, but it's technically correct. All right? So we deduce that the only way I'm not attending class would be if the alarm clock doesn't ring in the morning. All right? So any other reason why I would fail to attend class would be unaccounted for. Okay, so there's no chance that I could go out and try to start the car. It turns out it doesn't work. You know, the engine seized or something like that. No other conditions. So like class runs. Like I live an hour and a half away. I have a snowstorm. I'm snowed in, but there's no snow there, so they ran class. I didn't make it. That's not possible in this scenario. This is saying that the only way that I miss class is if my alarm clock doesn't go off. All right, so obviously not a realistic situation, because it would depend on a lot of things, like what time in the morning is your morning class. Okay, so it says morning classes, so you could assume it's probably more than one. But if they're two 1 hour classes, it's possible that your first class could start at 10 o'clock and go to 10:55, then 11 o'clock to 11:55. So the alarm clock, I don't know, would have as much of an impact in that situation as it would if your first class was 8 a.m. All right, so a lot of flaws with this one, but if this is assumed to be a true sentence, then each of the characteristics would have to be also true. All right, so, or also false, which we'll see in a minute. The tilde is how we represent the opposite of something happening. It's the not symbol. So if I put a tilde in front of a letter, it's interpreted as not whatever that letter is. All right, so this is what I was talking about before, the if-then sentence. I'm sorry. We'll get to the if-then sentence, the Tommy and the racetrack. Actually, let me write that down. I'm just going to chuck it down here. I'll change the sizing in a minute. And honestly, this isn't too far from the way some people think. They just think just by showing up at the casino or whatever they're guaranteed to win, like, oh, they just got to show up, throw some money on the table, and everything's going to work out just fine. Yeah, it typically doesn't work that way. But we'll come back to that in a minute. I just wanted to have it on paper. All right, so we can use truth tables to make a determination of which values of a variable result in a statement being true. So we'll start with a simple conditional. I keep saying conditionals. The simple connectives, and, or, if then, and if and only if. Okay, so the first one, and. So if you're not familiar with this notation, this is probably a good opportunity for you to try to reinforce it. This is the and. And honestly, as dumb as it sounds, or as brilliant as it sounds, I don't know, it's one or the other. I remember that as being the and because it was almost a letter A. That works for me in terms of mnemonic devices. That's really all I have to offer. This one is or because it's not the and. I knew one was the and, one was the or. Once I pinned down which one was the and, I knew the other one was the or. This is the conditional, but people have mentioned in the past that they think it's more useful to consider it the if-then. Or at least maybe not useful, but more relatable to refer to it as the if-then. All right. And the last one, that's just pure memorization. That's your if and only if. All right, and I'll give you something that might help you remember what the if and only if stands for in a few minutes, but not until we create the truth table. All right, so when we're thinking about the validity of an argument, what we're doing is we're looking at the individual phrases that make up that argument and their possible truth values. All right, so if I start off with something very simple, I am either drinking water. Oh, sorry, I'm getting ahead of myself. I am drinking water and I am wearing a black shirt. All right. I am drinking, not literally drinking water. I have a water bottle. I'll keep it even simpler. I have a water bottle and I am wearing a black shirt. All right. Common sense, not even the logic of it, tells us that that's a true sentence. Here I am with a water bottle and here I am with a black shirt. All right. So we're good for that one. It's the other ones that form the gray area, right? So again, my sentence is, I have a water bottle and I'm wearing a black shirt. So then, well, pretend this is not a black shirt. I usually have multiple shirts. I just take one off and it's like, oh, look, now it's pink. So just use your imagination. I have a pink shirt under this one. I tossed the black one away. I still have the water bottle though. But I'm claiming that I'm wearing a black shirt and holding a water bottle. But I'm not really wearing the black shirt. So the whole sentence can't be true. I'm lying about part of it. So it has to be completely a false sentence. All right. A good example is, I use this in my high school classes because it's seniors and they're all applying to college. So I would say for this, I am applying to, and then I would name two schools. I am applying to Duke and I am applying to Georgetown. Okay? If I'm lying about one of them, then it's a false sentence. All right? So I am applying to Duke and I am applying to Georgetown. Well, I didn't really apply to Duke. I applied to Ohio State or something, or Harvard, or pick a school. It doesn't matter. It's still a false sentence. And the easiest one to conceptualize is the case where both parts are false, because then you're just a complete and total liar. For a kid, I explain this by just describing chores. Your parent asks you if you took out, I actually have this example later, if you took out the trash and you did the dish, you did the dishes. The kid did only one of the two things. So, oh yeah, I totally did it. I totally did what you asked. And then they look in the garbage pail to see that the trash is still there. And they're like, well, you're full of crap. You didn't do what I asked you to do. It didn't matter that they did one of the two chores. The question was, did you do this and that? They're a pair. They come in as a package deal. All right? Now, if I tell the kid that in order to get a reward of some kind, they either have to mow the lawn or like two pretty intense tasks, right? Mow the lawn or vacuum the entire house. And assuming that the lawn isn't too crazy, because I grew up in a place where, at least for a few years, where it was 2.5 acres of property and it was all mowable. That sucked. It was like the whole weekend mowing the lawn. And for a good chunk of that, we lived in that place for like 4 years. For the first 2 years, we didn't have a ride-on mower, so it was a push mower. And my father didn't want clippings on the ground. So we had to bag up the grass and put it in a pot. It was a disaster. So it was like, you can either mow the lawn or you can vacuum the whole house. Vacuum the whole house, please. Vacuum, please. I'll do that. Sorry, sucker, you're stuck with the lawn. They're like, I hate you, man. I thought honestly, it's all coming flooding back right now. Like weekends, shot. Like it was, and the world's longest driveway. Yeah, just do me a favor, go out and shovel the driveway. I'm like, oh God, it's a snow day. Like, what am I supposed to do? So yeah, it was not a great childhood. But anyway, you give them the choice. As long as they accomplish one of the tasks, then they did what you asked them to do. You get the reward. So the reward is, well, this is back in the 80s, early 90s, so let's say $5. All right, inflation. So you get the $5 if you do one of the two chores. Now, if you do them both, the promise was that you will get $5. So you do them both, but well, good for you. You did two jobs. You're still only getting $5. All right. Bottom line is, the only way that this could be a false sentence is if you didn't do either of the two chores. That's the only way you don't get the reward. Now the conditional one, that goes back to what we were talking about before with the promise of a grade given a particular score. So I tell you, you get 90 or above, then you get an A. If I uphold that contract, you got the 90 or above, so that makes it a true sentence. I give you the A, so I upheld my end of the bargain. So true. You got the 90 or above, so you're true, but I didn't uphold my end of the bargain. So it's a breach of contract. I did not uphold my end of the bargain. So that's a false. The weird ones are the cases where the initial premise is not upheld. Right? So that's my Tommy going to the racetrack situation. Right? So if I'm telling you that Tommy goes to the racetrack is a false sentence, the question would be, what happens after that? Well, the reality is I didn't establish what would happen if Tommy did not go to the racetrack. I only established what would happen if he did go to the racetrack. So if that's a false sentence, then anything that follows that must be true because I'm not breaching the contract. All right? So if I don't give him $100, that's fine. He didn't go to the racetrack. So that makes that a true sentence. If I do give him $100, maybe I'm just feeling generous that day. I never said what would happen if he didn't go to the racetrack. So any possible outcome that would emerge from this situation would have to, by definition, be true. Right? So both of these would be true outcomes. So anything that's based off of a false premise, any sentence that's based off of a false premise is automatically going to be true. Just based off of the fact that there are really infinitely many outcomes that could happen. All right? It goes back to the grade example where I say if you get a 90, I give you an A. But I could still give you an A if you get a 20. I could still give you an A if you get a 130 if you got a ton of bonus points, or even a negative number, because I never said what would happen if you didn't achieve that 90 mark. Right? But I also don't have to give you that A because that's not covered in the agreement anyway. Right?
Sorry, you said if anything is based on false sentence?
A false premise, yeah.
False.
Right. This is the beginnings of why this just this one truth table is the beginning of why we need things like insurance claims adjusters and lawyers that work in insurance companies, basically insurance in general. Because if you've ever filed an insurance claim and been denied and then could not understand why you were denied your claim, it's because of this. Everything boils down, in terms of an implication, in terms of an if-then, it boils down to that idea, that single idea, that if you have a false outcome based off a true premise, then the entire sentence is false. So that's an instance where your claim would be denied, right? So you would think like, all right, well, that just means that it's going to be harder to prove something false. But you think about the situation in which something is proved false. Right? If you have what we call a binding statement, then it's pretty rock solid, and that's why lawyers exist, to take the language that you intend and make it binding, so that the loophole isn't created. Right? Because if you have a strong enough set of circumstances that establish truth and it's worded properly, then nobody could find the loophole around it because they can't get through the logic. Okay? But if you have flawed language in your contract, then it's very easy to see where somebody would go wrong, and really has to do with the false premises. But there's a lot of ways that these things could go sideways. Now the if and only if, that's it's kind of, I don't want to just give it to you because there's room to really discuss it, but it also kind of requires that we create an additional truth table on the side. So you just got to kind of squeeze it in right here. Just, well, not a full truth table, just the burden's on me because I got to somehow get this in here. We're just going to add another column here to this table. And that column is going to be Q implies P. So Q sideways arrow P. All right. So when you're looking at this, we're using the Q as the premise and P as the conclusion. So we're looking at our P and Q columns, but we're looking at them in reverse. So that idea where I was saying that any sentence based off of the false premise is automatically true, that becomes even more important because these are now your premises. And now we're looking at those in the direction of P. All right, so to get that last column, I'm saying true then true, false then true, true then false, false then false. So reading it that way instead of the way we did it originally. All right? So if you have that idea in mind that if you have a false premise, that it's automatically true, but everything else is going to, the only other situation would be true then false, giving you a false, then you're in good shape. Because it would tell us that that last column has to be true, true, false, true. All right, with the only false coming from the true then false. So then our biconditional, so it's like, well, why did we just do that? It just seems like you like doing truth tables. The biconditional is what would happen if you have P then Q, and then also Q then P. So it's a conditional inside of a conjunction. So what I'm looking to do here is apply my conjunction rules, my AND rules, to these two columns. All right, so we go back and also you can kind of see why we take such detailed notes because you're going to refer to these. So I go back here and I look at my rules for AND and I say, okay, well, what did we learn from this? Well, the only way a sentence is true is if both parts are true. All right, so I'm just making sure. Yeah, okay. Yeah, I was worried I was looking at the wrong thing. Yeah, so if both parts are true, it's a true sentence, otherwise it's not. Right? So we're looking at true. That's these two guys. I'm marking up that diagram too much. True. These two, false and true. Not true, that's going to be false. True and false is false. And then true and true would be true. All right. So we're getting at this, the idea that if the P and Q value has the same truth value to them, then the final result is true. But if there's any disagreement, then it's false. All right. This is the foundation of equations. If you think back to any kind of algebra class, the only time you were ever able to solve an equation is if you were assuming that both parts of the equation was true. All right. So that's just a subset of the two possible ways you could have an if and only if sentence be true. It could be both true or both false, but to solve an equation, we want them both to be true. Right? There are some circumstances in which you would want them both to be false, but can't really get into that without talking too much algebra. Yeah. Now, if your last column is entirely made up of true values, then what you're looking at is known as a tautology. A tautology. If a statement is always false, meaning that last column is made up of only false values, then the sentence would be called a contradiction. All right, so there's two ways to prove something. You prove by tautology or prove by contradiction, but tautology is the one that's more difficult, because what you're doing is you're proving something is always true under every possible circumstance. All right, so you say that something simple: I am the smartest person in the world. The burden is on me to now prove that I am smarter than every other person in the world. All right? Not practical, definitely. Probably not even true. I mean, I give myself a solid chance of it being true, but yeah, you got to figure I would have invented something like incredibly awesome if I was the smartest person in the world. Like a better version of a Tesla. Apparently, Elon Musk, right? That's the guy's name, Tesla. He wants it so that people sit in traffic. That's what my friend. I believe people when they tell me stuff, because I try not to like watch the news, because I have News 12. I had it on at home, and yeah, apparently lots of people died today in New York and Putnam County. It's like somebody died around right behind the Putnam Diner in Patterson, which is where I used to live. Somebody also died in it's in Rockland. No, it's Highland, New Paltz area. Like just the news was just about people dying and stuff, and I was like, I don't really like that. So I kind of rely on people to share with me the cool news, like interesting news, not the horrible, like humanity's going to hell news. So he told me, and I think it's true, there's no reason to make stuff up, that Elon Musk wants people to sit in traffic. Because what that means is that they're using his navigation software in the Tesla and also the autopilot. Autopilots in the Teslas they can't handle back roads very well, but they can handle major highways. So if his Teslas are sitting in traffic, it means people are using the autopilot. And I mean, that's an oversimplification. He doesn't want people always to be sitting in traffic, but when they have a choice of going on back roads or sitting in traffic, he wants them to sit in traffic. I'm like, all right, I'm sure there's a really, really intelligent way to figure that out. But I just determined, based off of that level of thinking, that I could not possibly be the smartest person in the world, because I just identified somebody who's smarter. You know, forgetting about the traffic thing, he invented a friggin' electric car that has autopilot. The autopilot would have been enough to sell me on it. Like, you're sitting in the car and you can activate autopilot and the car will drive for you. And he and his engineers came up with that. All right, so he's smarter than me. So what I did was I made a proof by contradiction. All right, so it wasn't a matter of me proving that I am the smartest person in the world. It was easier for me to prove that I wasn't, because all I had to do is find that one counterexample. All right, it's much easier to show that something is not true than it is to show something is true.
So then what would the statement come out to be then, if you're using a contradiction to prove the statement is?
You're looking to prove that the opposite, if you want to actually prove something is true by contradiction, you want to prove that the opposite of it is false. So if, for example, I mean, in my smartest person in the world example, it was just not feasible either way. But in the contradiction case, what I would look to do is operate under the premise that I'm not the smartest person in the world, and then look to refute that. Right? And it would have to be still case by case, so it would be a disaster. All right? But you can work with it on smaller scales, because again, if you prove the opposite of something is false, then the enemy of my enemy is my friend. It would necessarily have to be true. So, a simple sentence, P and Q, then P or Q. All right. Actually, we could even go simpler. And I'll change the next. I'll change the next example to make it the simpler one. I have moments of inspiration every once and again. We actually won't even need this column. We won't even need this column. I'm just creating typos now. So we'll actually do this one first. And then we'll do the beefier one. All right. So this one is saying P and Q, then P or Q. So we'll contextualize that in a second. But let's do the second one first, because finding the opposite of something would be pretty easy. If I tell you the possibilities for a sentence being true, for the truth of a sentence would be either true or false. So lots of edits on this one. So my first two entries are true and false, and then the bottom two rows are gone also. All right, because for a single phrase, the only way you could have a truth measure would be, because we don't do the maybes. There's no gray area when it comes to this. It's binomial, true or false. All right, so the opposite of true is false, and the opposite of false is true. All right, now this or sentence, we go back to what we learned above. The only way for an or sentence to be false is if both parts of it are false. That's not the case here. So this has to be true in both cases. All right, so we have a tautology here. All right, always a true sentence. All right. Now, I think about, when I go back to the smartest person alive. Maybe I'm not the smartest person alive currently, compared to my contemporaries, but maybe I'm smarter than some major historical figures. Like this tells me that I'm at least smarter than Shakespeare. All right, I got that just from this. Right, because like one of his famous quotes, and was it Hamlet? And I can't remember, soliloquies, monologues. I always get those confused. To be or not to be? Hamlet. That is the question, right? Is to be or not to be? That is the question. Well, it's not a question. It's a fact. All right. So to be or not to be. Well, we just proved that that's always a true sentence. So it's not a question. All right, so I would denote the be part, to be, as the letter P, the or with an or symbol, the not would be using the not symbol, and we're still back to the to be, which is still represented with the letter P. So that's what my proof was. It was related to that simple sentence, to be or not to be. We just proved, because it's a tautology, that it's always true. So when he said to be or not to be, that is the question. Well, it is not the question, because there is no uncertainty there. a question implies uncertainty, that there could be a yes or a no or a maybe. This is always untrue. Okay, so that's kind of a little taste of the power of using logic or tautology. However, it's still a beautiful quote, so you kind of know that in art, music, and movies, definitely movies. Geez, how many times you go to a movie and somebody says something, and you're like, that doesn't make any sense, but it sounds freaking cool. That's really what it comes down to. Like, it doesn't have to make sense logically. It just, it would be nice. All right. Now here's something that I don't believe is a quote from anyone, but this is also going to be a tautology. P and Q, then P or Q. So it could be something like, let P be like, I like pizza and I like soda. I like pizza. If I like pizza and I like soda, then I like pizza or I like soda. Like, that's just nonsense. At least the way it sounds. But it's logically correct. All right. So that's the language when you get into contracts. That's the language you got to deal with when you're dealing with a skilled negotiator, a person who puts contracts together. They use convoluted language like that to confuse you. That's the fine print. So that you read it, think you understand what it means, but you really don't. All right? And because it's a tautology, it locks you into, a contract that maybe you don't want to be part of, like Verizon. So, and sentences are only true if both parts are true. So this is just a repeat of the two separate truth tables above, just putting it all together. P or Q, or sentences are only true if both parts are, only false if both parts are false. So true, false. I did that again. And by again, I mean, when I taught this earlier today, I made the exact same mistake. True, true. I said it right in both cases. Said it right, but wrote it wrong. Can't stop myself. All right. So then an if-then is only false if you have a true implying a false. True premise, false conclusion. Did not uphold my end of the bargain. All right. So this would be all true. So we have a sentence that sounds like utter nonsense, but that utter nonsense is completely correct. Kind of like basically, you see a trial. I always think of the O.J. Simpson case, but you could have any other kind of legal case where you have a perception of the outcome and it didn't work out the way you thought it would. You're like, how did that happen? It's because the lawyers on the other side just out-logicked the other lawyers, so that's all it comes down to. All right. This was that taking out the trash and all that good stuff. So we assume that a child is good if this statement holds true, or this sentence holds true, and bad otherwise. So under what conditions is a child good? All right. And this is, it's also kind of iffy because, and I'll just read it. It's going to be weird, but it's basically saying, I've taken out the trash and I have either finished cleaning the dishes or I have not watched 5 hours of TV. Right. Again, it sounds like convoluted gibberish, but there's a lot of validity in there. It's just a matter of fleshing it out. Now, if you're having a conversation with somebody, you don't necessarily want to whip out a truth table to analyze their argument. You go with what feels right, what makes sense to you, and you just kind of hope that your sense of logic is reasonable enough that you're not going to fall for anybody's tricks, right? We'll get into the details after we construct the truth table. So P, Q, and R, like, and I list out all these possibilities for truth. There are 8 different ways that you can establish truth for 3 statements. All right, either they're all true, or they're all false, or any other arrangement in between. All right, so if I'm just looking at Q or not R, what I would recommend, I mean, not everybody needs to do this, but what I do suggest anyway is that you just tuck in a new column there. I'll actually use the line draw tool because that came out terrible. Tuck in a line, make a new column, and call that the not R column. I just got to clean this up a little bit. That's supposed to be like super tiny, but it's not. Just gonna live with it. So this is my not R. Just do it like this. Give myself a little bit more room. So not R would be the opposite of all the truth values for R. So false, 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 another false, then true, well, true the rest of the way. All right. So then Q or not R is comparing this column and this column. Or again, its truth value is based off of whether or not both parts are false. So the only way an or sentence is false is if both parts are false. So we're looking at a false here, and I believe that would be it. Everything else, nope, there's another one. And a false here. Everything else would be true. Oh, I caught myself just looking at the wrong things. I'm just going to double check. Now we're good. True the rest of the way. And then P and Q or not R. I mean, it's a lot, it's a mouthful, but it's basically saying for us to evaluate this column and this column using the conjunction. The rules for and tell us that the only way a sentence is going to be true is if both parts are true. Okay, so true, 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 and that's it. All right. So we have some possibilities for P, Q, and R. Lowercase. And just make a little table to represent the final answer. The possibilities for getting a true outcome would be if P, Q, and R are all true. The first 2 parts are true with the last one being false. And then alternating. Oh, actually, no, it's just true, false, false. All right, so what we get from this is different ways in which this child can be good, can be considered good. Okay, what they'd have to do is take out the trash and clean the dishes, and really, you basically do all 3 of these things. Right? If they do all 3 of them, they fit the criteria for being considered good. That kind of makes sense because you're going to take out the trash, and you'll have a choice of one of these 2 things. So you can kind of look at it and say, well, the taking out of the trash has to happen. So even before you get started on the process, you could have eliminated these four possibilities, right? Because those could never have been true, right? These four possibilities could never have been true because one condition that needed to occur is that the kid had to take out the trash, right? Then one of the two other possibilities had to happen, at least one. So had to either clean the dishes or watch 5 hours of TV, right? Now, 5 hours is an oddly specific number, so does the kid have to hit the mark? Is 501 okay? Is 499 okay? Well, according to the contract, no. He would not have satisfied the requirement of 5 hours of TV if he hit any amount other than 5. Okay? So it's very, very specific in that regard. But assuming that he did one of those two things at least, then he would have been considered a good child. But the condition here is really, when you look at it, it doesn't really matter what's happening here because he could have done neither of these two things and still been considered a good kid. So under what conditions is the child good? If he takes out the trash. So the child is good if he, she, gender non-specific. All right. It really doesn't matter that one of those components is actually a reward. Why the hell did that happen? All right. I'm going to lose my mind. There's no I'm not even touching that part of it. Bless you. Try it now. I honestly really just hate this software. Bless you. All right, so that's kind of a weird thing to think about, but you know, the more you think about it, the more obvious it becomes, I think. So I'll put a star on the next one so that you could have fun with that one on your own. We got to get into logical equivalence. Bless. So for this one, we kind of have to really get into it. Two statements being tested for equivalence. This V is not the right. I don't know why I put it like that. It's not the right V, so I'll take that as a typo. All right, we're testing these two for equivalence, and again, equivalence is determined based off of a tautology. So if you have the need to test whether two statements are equivalent to one another, you can create a truth table, and then from there, as long as you get a tautology, then you'll know that there's equivalence. This should be a biconditional. So double-sided arrow. All right, so true, 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 false, false, true, false, false. We look for the opposite of P. Opposite of P would be everything in the P column just negated or reversed. Trues become false, and false becomes true. For this sentence, not P or Q. And again, you can look at the context of it, but basically what this is saying is if I study, then I'll pass the test is equivalent to if I don't, either I don't study or I'll pass the test. All right? So that's what the question is, whether or not that's equivalent. Right? And it's a weird thing to think about in terms of whether or not that, I mean, the second sentence doesn't even seem to make sense, but it is worth investigating whether or not there is equivalence there. All right, so we're looking to see if these two will form a reasonable conclusion to another premise. All right, so if either part of it is true, then the whole thing is true, and that is the case. Oh, sorry, there's one where it's false. P implies Q is an easier one because all you're looking for is that one true-false situation. True then false, that is. So we have true, false, true, true. And so we do have a tautology because for a biconditional, if they're the same, you have equivalence. All right, so trues down the line. I remember I teach this to ninth graders. This is where it would end. There are Regents exam problems where it's just to do this. They'd never actually conclude anything from it, and that's kind of the problem. And I think that's why I got phased out. But we do need to make a conclusion from this. All right, so the first part of the sentence, P implies Q. If I study, then I'll pass the test. And you also got to think about like different ways you can rephrase, because if and while, that mean they kind of go hand in hand. Right? So, or who's to say that you have to lead a sentence off with the word if? You could say, I'll study if I'll pass the test if I study. That's the way people speak. You would probably not say, if I study, then I will pass the test. It's choppy. You say the reverse of it. You say, I'll pass the test if I study. That's kind of like the way you want to think about it. And so when you reason it out that way, it should make perfect sense. Now the second one, that's the crazy one. All right, so I do not study. Oh, let me put the symbolic representation first. So P, not P or Q. So I do not study. Or I'll pass the test. All right. That's the structurally correct way of writing it. But you have an or in a sentence. You could always throw in the word either. Just like if you had a nor, you could throw in a neither. You go hand in hand. Sure.
So for the first one, where it's the box, so not P or Q, how is that true? Like you're saying, I don't study test. Is it because it's possible to pass the test without studying? Is that what you're saying?
Yeah, essentially. Yeah, so you have outcomes here in this column specifically where you could have cases where I did not study, specifically this one here,
Yeah.
but you still pass the test.
It's like possible.
Right.
So the second one is he didn't study and he didn't pass the test.
Right, and that's the
How
only
is that
way.
false?
He doesn't study or he doesn't pass the test. right? If either of those outcomes are if either of those outcomes are true, then the whole sentence is true. But if both parts of those outcomes are false, then the whole thing is false. Right? So now when you look at it like this, either I do not study or I'll pass the test. It just seems like it's nonsensical, but technically it's logically correct. And not only is it logically correct, it's equivalent to this sentence. If I study, then I'll pass the test. And so now you kind of see, hopefully, the trickery that happens out there. Because a person who, I refer to them as logicians, and that's the correct term, but nobody ever says that. It's an archaic term. But what they do is they take the real, people sentence and they convolute it into something that seemingly doesn't make sense so that you don't read the fine print. I mean, when you're signing up for a Google account or something like that, you're supposed to read the terms and conditions. Nobody ever reads them because you're likely to see what I have written there in blue, and it's not going to make any sense, so you don't even bother. And then you find out that they sold all your information. Right? You're like, why do I all of a sudden have all these people calling me up, trying to sell me stuff? It's because Google sold your personal information because you told them that it was okay to. And that's how it is. And I'm like, how did they get my new number? I just changed my phone number. How did they get my new one? Well,
Does scam likely always call you?
yeah. But, that's the thing. Like when I change it on Google, Google's still selling my stuff. So the only thing in that terms and conditions that they promise not to sell is your username and password. That's the only thing. But they could sell your email address, which is basically selling your username. So, it's just so much that they can get you from the blue here because you can't necessarily make the connection between the red and the blue. All right. So, I'm going to put a star on the next one because it's kind of along the same lines. And again, I don't want to steal the joy of you tackling those on your own. I just got to remind myself, look at these babies. We'll get to this in a few minutes, but this stuff is going to really simplify things. Although when you look at it at first glance, it doesn't look like it could ever possibly be simplifying anything, but this is going to help. Contrapositive of a conditional statement. I'm just going to put stars immediately on the truth tables because they're going to really describe visually what I'm telling you anyway, but I do want to just kind of state the relationship because I don't want to do all the truth tables for you. I want you to have some fun with it. Yeah, it'll be a group assessment at the end of class. Yeah, so we'll do beginning of class, we'll do some material, and then after that it'll be open notes assessment with groups. So yeah, we have the conditional sentence P implies Q. The inverse of that is where you're just going to negate the premise and the conclusion. You're negating both parts. All right. So I mean, I could put it in words, but it doesn't really kind of beg the need for that. You're just taking each part of your sentence and negating it. All right. This will not have the same truth value as the original sentence. So I'm just going to try to type it because I'll be here for the next half an hour trying to write it. Does not. And I got to figure out something with that default. That's just ridiculous. I just want to be in the focus group for whoever decides when you open Microsoft Word, for example, that the font should be Cambria or whatever the hell it is, size 11 with 1.5 space in between. I don't people are making decisions for me and it's really pissing me off. And now I can't even get rid of this. I get this big does in the middle of the screen and I can't even edit it. And there it is. Drop down, you son of a gun. Oh, now the mouse doesn't work. All right, so does not have the same truth value as the original sentence. And that's the same for the converse. Neither of these two things have the same truth value as the original sentence. So I'm going to highlight those. And this is the source of aggravation for people around the world. Because, and I'll go with a simple sentence. Alright, that wasn't weird. If it raining, taining, no. You can see why I make typos all the time. I just can't type. I will get wet. Alright, if it is raining, then I will get wet. Make that red. Very simple sentence, something that you can conceptualize, relate to. I suppose it's not always true, right? Because if it's raining and you're not outside in the rain, then there's no reason to expect you to get wet. But the inverse of that would be, if it is not raining, then I will not get wet. Right? If it's not raining, so maybe a sunny day out, then I will not get wet. Right? That kind of makes sense, but what if somebody dumps a bucket of water over my head? Right? It is not raining, so it's snowing. Then I will not get wet. I'll get snow on me, and then that snow will eventually melt, in which case I'll get wet. Right? So not necessarily true either. If this one is true, just by negating both parts, we can't assume that the resulting sentence would also be true. The converse is where you flip them around, the premise and the conclusion. If I get wet, then it is raining. Well, that one is absurd. Right? Maybe I just took a shower. You know? And what kind of wet are we talking about? Like washing hands wet? Or full-blown shower? A little bit of like a drop of water? Like what are we working with here? Right? So a lot of different possibilities, but just as one simple example, although it doesn't prove the relationship, these prove the relationships. It does give you a good conceptual way of understanding what those relationships are. Right? Now, taking that sentence and applying what's known as the contrapositive. All right, so let me clone that bad boy, bring it down here. Clone it again and edit it. The contrapositive is when you switch and negate. Switch your premise with your conclusion and negate both. So if I am not wet, or if I will not get wet, then it is not raining. And we're going to go blue for that one, for those keeping score at home. All right, so that would be my contrapositive. Now, we're not really looking to determine if it's true rather than false. We're just looking to determine whether it has the same truth value as the original sentence. All right? So that's what we call logical equivalence. So these would be logically equivalent. All right. So that's telling me that if the first sentence is true, just by taking the contrapositive, I've created a new sentence that is also true. Right? If the first sentence is false, I've created a new sentence that's also false. But if you reason it out, if it's raining, then I will get wet. Right? Now, let's assume it's a true sentence. I'm standing outside, it's pouring rain. Yes, true, I got wet. All right? Standing outside, if I will not get wet, then it is not raining. All right? I did not get wet, so it would make sense that it must not be raining, assuming that that first sentence was also true. All right? So now if that first sentence is false, then the second one would be false as well. So if it's raining, then I will get wet. I'm standing inside, false sentence. All right? Because the raining has happened, the premise has happened, but the conclusion was not upheld. Right? I didn't end up getting wet. Right? So the contract was broken. Turn that around, if I will not get wet, so I'm nice and dry, right, then it's not raining. You can't make that assumption that that would be a true sentence. All right.
So we can basically create our own PAQs.
Yeah, you're still going to use the same arrangement of true, 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 false, false, true, and false, false. You got to account for every possible pairing of true and false.
Right, so we would put like T, T, F, F for P,
Yep,
and then for Q the same, like as the example on the
exactly. Here's a nice juicy typo for somebody. This table has one too many cells. I think the others are fine though. All right. And so the examples below, they're going to follow the same rationale. All right. So we have if Simone takes chorus, let C represent that, then she cannot take Spanish. All right. Now, an example of why that might happen would be a time conflict. Right? Spanish and chorus are happening at the same time slot. So if she's going to take one, she can't take the other. That makes sense. All right. If Simone takes Spanish, then she cannot take chorus. All right. So what we're looking at is our first attempt at making a proof, because instead of actually making a full-blown truth table out of this, we could rely on the fact that we just determined that contrapositives are logically equivalent. All right. So, and that's all we're looking to do here. All right. So what we would do is we would establish our premises. Well, a simple way of saying it is to just call them the givens. And our given statements are C implies not S, and S implies not C. Conclusion: C implies not S would be logically equivalent. Biconditional is a symbol for logical equivalence. All right, either both true or both false. And that would be by the law of contrapositives. I never know what folks' backgrounds are in the college level. Some people have seen some proofs before in high school, little geometry proofs or even logic proofs. If you have, you might have seen them organized in statements and reasons. I never understood that in terms of just making that a general rule of thumb for writing a proof, it's very rigid and not very flexible. You do need to make a statement and provide a reason, but there's no convention by which you need to do that. So that whole, if you're a statements reasons person, you don't need to make a table out. So what we did here is that, like, you draw your conclusion and state what the relationship or rule was that allowed you to draw that conclusion. Right? There is an underlying assumption of equivalent vocabulary. Right? So I always have that in mind. Like, if you're speaking my language, there's no reason why you should have to define the terms in that language. All right? So you say law of contrapositives, you don't have to then tell me what the law of contrapositives is. It's just telling us that two sentences that are contrapositives of one another are logically equivalent. All right? But that would be, honestly, I equate that idea to, like, if we were having a conversation and after each word in our conversation, I gave you the definition of each word in that conversation. All right, that wouldn't make sense. There's some things we could just assume as facts, and the law of contrapositives is one of those things that we can now assume because, even though we didn't actually prove it, these stars mean that they're going to get proved at some point. These are not going to be a tautology, justifying that these are not logically equivalent. And this one will be a tautology justifying that contrapositives are logically equivalent. All right. So every time we cross a bridge, we can now kind of add it to the list of things, in our toolbox, whatever analogy you want to use. It doesn't really matter. All right. So at this point, let's take 5, and then we'll get into some other types of proofs. I lost track of what page. Is this all one video? That might be the case, actually. Yeah, so let's take 5. I'll start uploading some videos, and then we'll do maybe like another 20 minutes after that, and then I'll get you out of here. Because next class is going to be an assessment, so I didn't want to do an assessment this class and then immediately, like a bigger assessment, because the one that we're talking about next week is going to be the one that counts as a unit test grade. All right, so but it's still a group assessment, and it's still going to be open notes, but it's going to be a little beefier. All right, so I don't want to do a double dip. So 5 minutes, we'll resume.